All right, so welcome back. So this time, today we're going to be in section 5.2. We're going to learn about using the addition rule for disjoint events, the general addition rule, and then we're going to compute the probability of an event using the complement rule. So we're going to be doing a little bit of math, but it's not crazy math, and it's going to tap into your fraction use a little bit, fraction math, but it's nice thing is we're going to try to keep those denominators common, so it is easy fraction math. Not that I doubt your abilities to do fractions, I just know that very few people like them. So let's get with it. So two events are disjoint if they have no outcomes in common. Another name for this is mutually exclusive. So, for example, if you roll a dice one time, we can't have both a 3 and an even number occur at the same time. Or remember that bag of M&Ms back from section 5.1? If I pulled an M&M out of a bag of M&Ms, it's not going to be both yellow and blue. It'll be either yellow or blue. They're mutually exclusive. They can't be both. So these are disjoint events. So the addition rule for disjoint events is pretty simple. If E and F are disjoint or mutually exclusive, then we just add their probabilities together. So let's say that I wanted to know the probability of rolling a 3 or a 5. So one thing important when we're looking at disjoint events, the word or is going to be in there. So a 3 or a 5, so the probability of rolling a 3 would be 1/6. The probability of rolling a 5 would also be 1/6. So my probability of rolling a 3 or a 5 would be 2/6 or 1/3 if I simplify that. So it's really that simple. So, but if I had like many disjoint events, so if I had the probability of pulling the King of Hearts or the Ace of Spades or the Queen of Diamonds or the 10 of Clubs, if I had several different things, we would just add all of those probabilities together, but only if none of them have any outcomes in common. So they all have to be disjoint. They can't be the same. They all have to be mutually exclusive. So I would add all of those probabilities together. So let's look at the probability model here. It shows the distribution of the number of rooms in housing units in the United States. So our population is the United States. We're looking at the number of rooms in housing units. So we're going to talk about how to verify that this is in fact a probability model. This is something you're going to want to write down. So make sure that you write down what it is, because on a test, very likely, I will ask you, is this a probability model? And you'll need to know the two things you have to look for. So first, all of the probabilities need to be between 0 and 1. They can be 0 and they can be 1, but they have to be between 0 and 1. All of these probabilities in this probability model that I have right here, all of them are between 0 and 1, so we're good there. The second thing we need is they all have to add up to 1. So I add all of these numbers together, they're going to add up to 1. So those are the two things. So between 0 and 1 inclusive, and they add to 1. Now there are times when you are going to be rounding values, and rounding values may cause you to be slightly over 1 or slightly under 1. That's normal, that happens. So you might end up with 1.01 or 0.996. That's okay. But if you end up with 0.95, it's probably not from rounding. It is probably not a probability model. So it'll clearly be not a probability model in a question if I give you a question. And I'm going to make sure that they add up to exactly 1. But when you're checking your own work, if it's slightly off, that's okay. Make sure that you write down, like when you're showing your work for the test, make sure you write down slight variation due to rounding or something like that. Write something on there so that I know that you understand what you're doing. Okay, so let's talk about how we use the addition rule here. So I'm going to add all of the, we know that this is a probability model. We want to know what is the probability If a randomly selected housing unit has 2 or 3 rooms. So there's no house that's going to have both 2 bedrooms and 3 bedrooms, or both only 2 bedrooms and only 3 bedrooms. So I'm going to look at these two right here. So I'm looking at probability of 2 or 3, and I'm going to add the probability of 2 plus the probability of 3. So I get 0.032 plus 0.093. So I'm going to add those numbers together, and I get 0.125. So the probability of a room of a randomly selected housing unit having 2 or 3 rooms is 0.125, or 12.5%. Okay, if you have a question, make sure you send it to me in email or my open math. I would like you to do this one. Once I give you the problem, I want you to calculate this yourself. Pause this video and then come back and we'll do it together. So first you're going to compute the probability of the event drawing a king. Then compute the probability of the event drawing a king or drawing a queen or drawing a jack. So go ahead and go and come back. All right, so hopefully you calculated those. So first let's start with drawing a king. So here's my 4 kings right here. There are a total of 52 cards, so we have probability of king. That's how you would write that. So it's 4 out of 52, which simplified is 1 out of 13. If you want to turn that into a decimal, that would be 0.077 approximately, so about 7.7%. So now we're going to do the probability of king or queen or jack. So we'll go back up here. So there's 4 of each of them. There's still 52 cards. So I'm going to say equals 4 out of 52 plus 4 out of 52 plus 4 out of 52. Or if you wanted to do 1/13 plus 1/13 plus 1/13, that's fine also. And we ended up with 3/13 or 1252. So 3/13 simplifies, I'm going to write it over here because I ran out of room, about 0.23. So about 23% chance of drawing a jack or a queen or a king. Hopefully that makes sense to you, so we're going to move on a little bit. So now if we have 2 events that are not disjoint, so sometimes we have things that aren't disjoint. So for example, what if I said something like, what is the probability of rolling a 3 or rolling an odd number? Rolling a 3 or an odd number. Those are not mutually exclusive. So I would say probability of rolling a 3 or an odd number. Since the 3 is part of the odd numbers, when I do, just a second here. When I do the probability of 3, which would be 1/6, plus the odd number, which would be 3/6, I'm counting the 3 twice because the 3 is part of this and it's part of this. So I have to subtract off the overlap. So when 3 is counted twice, I have to take one of those 3's out of there. So my probability then would be 1/2 or 3/6 or 1/2, because these basically cancel each other out. It is not always going to be the case that you cancel the whole thing out. In fact, we're going to do an example in a second where you don't. But my probability of rolling a 3 or an odd number would be 1/2. So you add them together and then you subtract the overlap. You subtract where they overlap. So if I had Venn diagram, so I'd have 1, 2, that's not good. So I would have, so like 1, 3, 5. That's not going to work at all. I would need 3. Never mind. Ignore me here. Okay. Moving on. Okay. So computing the probability of, and these are not disjoint, so they're not mutually exclusive. So we're going to compute the probability of, I don't want that black color. Uh-oh. I'm going to pick a different color. Let's do blue. So the probability of king or diamond. Okay, so we have our kings right here. I'm going to highlight them blue. So here's all my kings. So this would be, we already had that was 1/13, but I'm going to do 4/52 just to keep that. And then let's take a look at my diamonds. These are all my diamonds right here. That's a really beautiful drawing, right? So my diamonds are 1352 because there's 13 diamonds. Okay, so as you can see right here, I highlighted the king twice. I highlighted that twice, so that's overlap. So I've counted that king twice. So I need to make sure to separate that out. I need to subtract subtract one of those kings because that is the overlap. So I have 1652. So I have 1652, which that simplified fraction is 4/13 or 0.308 approximately. So there's a 30.8% chance of getting either a diamond or a king. If you have questions about this, make sure to email me or send me a message through my Open Math. I would like you to do this next one on your own. Probability of rolling a 6 or rolling a multiple of 3. Do this one on your own and come back to me. So go ahead and pause this and go ahead. All right, so hopefully you did this. So I'm going to highlight all of these 6s. Rolling a 6. I'm going to circle them, sorry. So this is all, this diagonal right here is all of the 6s. And then multiples of 3. So these are 3s. These are multiples of 3s. That's a 6. These are multiples of 3s because that's a 9. And then that's a 12. So let's write this down. So a probability of a 6 or multiple of 3. So the probability of rolling a 6, I have 1, 2, 3, 4, 5 6s, so 5 out of 36. Multiples of 3, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 36s. And the overlap. Now this is one of those cases where I can subtract all of them because all of them were counted twice, so that's 5/36. So those are going to cancel out. So this is 12, sorry, because I can't count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, I can't count apparently. So 1/3 or 0.33, so about 33 1/3%, 1/3 of a chance. Okay, the complement of an event. So complement of the event is a way that we say not, that something didn't happen. So basically, like say, what is the probability of not rolling a 3? So when we know that on a dice we can get 1, 2, 3, 4, 5, 6. And we know that there's a 100% chance I'm going to get 1, 2, 3, 4, 5, or 6. So that 100% chance minus the probability of getting a 3, so probability of not 3, would give me 5, 6. So there's 5, 6 probability that I will not get a 3 when I roll those dice. When I roll the dice, there's a 5/6 probability that I will not get a 3. Does that make sense? Let's do an example. According to the American Veterinary Medical Association, 31.6% of American households own a dog. What is the probability that a randomly selected household does not own a dog? All right, so we are going to say probability of not dog. Okay, I think I have it there. So probability they do not own a dog. So we do 1 minus the probability of owning a dog. So 1 minus 31.6 or 0.316. Let me do this one more time. So 0.316. So the probability of not owning a dog is 1 minus, so 100% minus the 31.6%. So 100% minus the 31.6% would give me 0.684. So there's about a 68.4% chance that somebody does not own a dog, or the probability someone doesn't own a dog would be 0.684. I would like you to try this one just one moment. There are a total of, I added all of these together, so there are 318,800 residents in Hartford County. This table, this tells me how many people have these different commutes. So 24,358 people have a less than a 5-minute commute. We know that the probability of a randomly selected resident having a 90-minute or more commute would be this over the total number. So 4895 over that total number of people. This is my probability that a person's commute is 90 or more minutes. I would like you to pause this for a second and calculate the probability that someone's commute is less than 90 or more minutes, or less than 90 minutes, using the complement rule. So use the complement rule to figure out what the probability of someone having a commute less than 90 minutes is. Pause this, figure that out, and come back. All right, did you figure it out? Okay, so we know that this right here is the probability someone has 90 or more minute commute. So the probability somebody having less than 90 minutes would be 1 minus 0.015. So 1 minus 0.015 would be 0.985. So the probability less than 90 is 0.985. Hopefully that made sense. Final problem, and I want you to figure this out on your own. If a 25% of a deck of cards have the suit of hearts, what is the probability you will not draw hearts if you randomly draw a card? The probability of not hearts. So go ahead and pause it, figure that out, and come back. I think you probably got that pretty easy. So the probability of not hearts would be 1 minus 0.25. So the probability of not hearts is 0.75, or 75% probability you would not draw hearts. Hopefully that all made sense. Come back to me and ask me questions if you have any. Talk to you later.